Okay. For starters, I completed my homework. I cleaned up the slides at least good for me. I cleaned up the slide. I'm gonna make him bad again, but just believe me when I tell you, when I get to the exams, I will go through the slides and I will tell you which ones are important to study for the exam. All right, I'll do that ahead of the exam. Um, just, just deal with the nutty professor thing. It's just the thing, and I'm probably not going to change. So, secondarily, thank you. A lot of you did already update your Google Colab to make sure that I got invited, but a couple of you didn't. So I put in another request. So if you haven't already done that, uh, get that updated so I'm able to see your code. I'm not grading them hard or anything, just I need to make sure you did it and I pretty much give you full credit. I might make a couple of comments or something, just get in the habit of making sure I have access because as we get into more complicated things, it'll be more important that I have access. All right. Okay. So let's see. Is this even this class? This isn't even this class. That's how cleaned up I got those things. All right, this looks better. All right. Look at that. The last thing on there is is the last thing we did in class. It's awesome. All right. So, oh, somebody's chatting. Was there hopefully they can hear me and stuff. Oh, they said they can't hear my audio. Um, Everything's set right on my side, and the audio thing seems to be going. So I'm guessing, Landon, that it's something on your end. Um, yeah, but the recording should have the audio in it. Well, maybe I should tap that to type that to him since. All right. So what we did at the end of the last class, as we're transitioning into actually starting to write some code now, and we'll introduce some things as we go through, is we tried to come up with this idea of like, okay, we have this we've learned about all these number conversion things. We have two different patterns that we're working with, and then there's this little twist ninja move in the middle of converting 10 to A or A back to 10, depending on the pattern. So we went through and we kind of did this pseudo Cody type thing, and we said, okay, here's if I give you a whole bunch of little tools on the table, I say, explain to me using what you have available to you how to convert um, some hexadecimal number in this case into a decimal number programmatically. And we could have replaced hexadecimal with an octal number, with a base 6 number. Didn't matter what it was. We're going to ultimately write base to decimal when all is said and done here. But we're going to start off just looking at this one example. All right. And let's see, yeah, we start off with binary. So actually, I want to implement this one first. That way we don't have to do that ninja move mapping thing the first time. All right, so when we wanted to convert 1010 binary to decimal, what we did is we kept track of the initial value. And we're going to see this in code. I'm just going to walk through this here real quick. Um, we'll see this here in code. Let's see if he gave me a response. Okay, he's good. We're going to see this here in code beforehand. So we're going to store our initial value. In this case, we're just hard coding 1010. Remember, when we use this pattern, when we're going from some base to decimal, we start at the far right-hand side of whatever the number is, and that's the ones place. That is whatever the base currently is to the 0th power, which is always the 1, which is always the ones place. So place will start off at 1. As we're working through it, we're building up a sum. So we're going to have to remember our sum. So we'll create a variable here for sum. I was changing things as we were going through there. But so pos starts off at 3. in this particular number, because the length of this guy, 1010, the length is 4, which means the legal buckets are 0, 1, 2, and 3. So the last bucket, the last legal position in this guy is at position 3. And we'll see that in real code here in a few minutes. All right. So now we want to repeat some stuff. Remember, human beings solve problems by remembering stuff, asking questions, and doing repetition. All right, so we're going to keep doing stuff below until pause ultimately becomes -1. Because what's happening to pause as we're doing our conversion? We start off at the 1's place, to the 2's place, to the 4's place, to the 8's place. So we keep walking there. So pause is bucket 3, then bucket 2, then bucket 1, then bucket 0. And when it becomes -1, we have finished going through the entire thing we're converting. All right. So we're going to keep doing this thing until we've checked all the buckets. All right. So then we're going to go ahead and grab whatever the current bit is, 0 or 1. So we're going to get whatever that initial value was, this guy 1010 at position pause. So position 3, that is the last bucket in there. That's a 0. All right. And so then we're going to say sum is equal to whatever sum starts off at, which is currently 0, plus whatever the current place is, which is 1, times the current bit, which is 0. 1 times 0 is 0. We'll add 0 onto our sum. Our sum is still 0. Then we're going to update place to be place times 2. Since we're dealing with binary, the 1's place becomes the 2's place. The next time through, it'll be times 2 the 4's place. The next time through, it'll be times 2 the 8's place. So on and so forth. All right, so update place, update pause. Pause used to be at the very end. Now it's one position before that. All right. We're going to keep doing this over and over and over and over again until pause finally becomes a -1. When it finally becomes a -1, we'll print out the value of our sum. Going to be a 10 in this case. All right. So that is our, call it pseudocode algorithm. This isn't a Python thing. This isn't a Java thing, whatever. This is just coding logic using nothing but memory, asking questions, and repetition. Make sense? All the problems I'm going to ask you to solve for right now, I always want you to solve them in terms of what you already know. Or in terms of something relatively simple, you can say, okay, how do I do this? And we'll see. I'll cover that as an example today. All right, so let's go and actually write this. So I'm going to do this inside of online GDB because it's easier for me to share the link to just the code we wrote. So I'll select Python as my language. Hide floating meeting controls. Okay. I like to, whenever I'm working with a program, I usually write a little hello world program right off the bat just to make sure all my development stuff is working. So whether you're using Google Colab or you're using online GDB or Visual Studio Code, whatever tool you're using for writing code, write a quick little hello world program, make it run, make sure it says hello world. Then at the very least, all your stuff is talking to each other correctly. All right, so then from this point forward, any problems that you have, you've added to, you've created those problems. All right, so we're going to create a initial value. Now we can represent this a couple of different ways, but I'm going to go ahead and represent it as a string, and we'll talk about strings and arrays. Effectively, we have this, you've just started exploring it a little bit on your homework assignments, but we're going to see it by example. It's not overly difficult, but believe it or not, built into modern programming languages, we have the ability to remember things, whether it's set values like our primitive types, integers, floating point values, booleans, or collection types. In this case, we have a collection of characters which we usually call a string. And most programming languages have functions, things that you can do to strings to make them work. Okay? So we have our initial value there. Let's paint by number. So that we're going to have place is 1, sum is 0, pause is 3. We're going to hard code it for now, but then we'll make it more generic. So we'll say place is equal to 1. Sum and pause. Sum is 0. Possible sum is already taken since it's in red. It might yell at us. Let's call that answer. There's probably a function in Python called sum that if you pass it a list, it sums up all the stuff in that list. So a lot of times we have these reserved words in programming languages. So if you happen to create a variable that uses a name that's already built into the language, like for instance, you can't have a variable named if, because there's if statements in our programming languages, and that is a reserved word. So don't name your variables if, that kind of stuff. All right, so we'll have our answer is currently 0, and then pause will start off at 3. We'll make that more generic the next time through. Let's just see this work at first. All right, so now we want to keep doing something until something is true. So we're going to keep doing all this stuff here until pause is equal to -1. So I'm going to do this as a while loop. We'll talk about our different kinds of loops once we see this going. So I'm going to say while pause is not equal to -1. I'll come back and talk about the formatting. If Python has one good thing going for it, and I'll come to you. If Python has one good thing going for it, it's that it forces indentation. As a whole, I don't really like Python as a first language. It's not structured enough, so it kind of lets beginning programmers get away with a little bit too much. The guardrails are not as tight as I think they should be, but it's a very common and popular language, so that's why we're using it anyways. But one thing that beginning programmers typically struggle with is writing code that uses proper indentation so that the code is more easily readable. All the stuff that belongs to an if statement is indented underneath that if statement, for example. Languages like C, C++, Java, C#, they are perfectly fine if you put the entire program on one line. Not readable by a human being, right? Because all the statements in that language end in a semicolon. So there's a way for the compiler to process through it, to parse out your statements, even if you decide to write it in a way that's not readable by a human being at all. Not the end of the world. Most C and C++ programmers would not do that. They would put it on multiple lines. They would indent. But one of the things that beginning programmers are notorious for is not indenting their code. Everything is left justified. And then when they have problems, it's very difficult to see what belongs with what until you clean your code up a little bit. Modern IDEs, integrated development environments like Visual Studio Code or similar, have usually a function called like prettify code or something like that, or you click a button, it makes it look better. You should probably make it look pretty good to begin with. Go ahead. You had a question?
Oh yeah, I was gonna say that use a for loop for the number of values in the initial.
Absolutely, we can. Yeah. I'm making it match what I wrote before. We'll talk about the different kinds of loops. Yeah, in this case, we know exactly how many times we're going to go through this. For loops tend to lend themselves to counting type numbers. Probably would be the better fit here, but they both accomplish the same thing. We'll see that while loops and for loops have a lot in common. Okay, so as long as pause is something other than -1, that's what this says. As long as pause is not equal to -1, then what do we want to do? Well, we want to extract the current bit from our value. So I'm going to say cur bit is equal to initial value at position, pause. All right, so initial value is a string. It's a collection of characters. I'm saying give me the specific character at position pause. All right. Now, when this guy comes out of that, we can see here that our official, so that last value there is a 0, right? It's going to come out of there as the char 0. Now, if we go, let's see. ASCII should be good enough. That'll be easier to read anyways. All right, let me find the character. We have it as an alphabetic character, or is it all? Yeah, here we go. So right here, I have the character 0. And the character 0 is equal to the decimal number 48. We know ASCII Unicode, that's this mapping between things that human beings like to see, visuals, with the math that keeps track of what this actually means. Right now, the thing that I have extracted from that string is not the number 0. It's the character 0. And under the hood, the character 0 is actually stored as the number 48. So if I were to try to do math with that, it won't be treating it as a 0. It'll be treating it as a 48. Not what we want, right? So we need to have a mechanism for kind of squeezing the numerical equivalent out of this character so that we can do mathy stuff with it. All right. In Python, let's call it 98% certain. I code in a lot of different languages, so we're going to see pretty quick. Where's my oh, is this it? There we go. There is a function called int. And when you pass something to that function, something that is, intable, something that it would make sense to convert to an int, in this case, the char 0. If I said, what is the int version of that? All of us can pretty quickly say, oh, it's probably the number 0. That would be the integer version of that. That's what int does. Int's this little function. Can I make this larger? I think I make this bigger. That everybody can see that better, I assume. I certainly can. All right, so this guy right here, int, is a function. And this guy takes whatever you pass it and converts it to its integer equivalent. So now I have a number stored inside of CurBit. Make sense? All right, then I'm going to take my sum. I'm going to set it equal to whatever my sum currently is plus place times CurBit. So sum is equal to sum plus what? Oh, thank you. Appreciate it. Answer is equal to answer plus place times.
Does Python do plus equals?
They do.
Okay.
I just purposely don't teach compound operators until a little bit later. Place times CurBit. This is if this is the ones place, you're multiplying it by the value here. This is CurBit. This is the twos place. You're multiplying that by this thing. This is the fours place. You're multiplying that by this.
Yeah.
Yep. All right. So answer equals answer plus place times CurBit. Then what are we supposed to do? We're supposed to multiply place by whatever base we're coming from. In this case, we're working with base 2. So we'll go ahead and multiply place times that, and we're going to say place is equal to, we're updating the value of place, the value of that variable, place times 2. So place used to be 1, now place is 2. Next time through, place will be 4, so on and so forth. All right, then pause is equal to pause minus 1, because we've gone from the last thing in my initial value to the thing right before the last thing. So instead of bucket 3, it's now bucket 2.
You don't start at 0.
We're starting at the end because that's where the ones place is. This guy right here, this is the ones place, the twos place, the fours place, the eights place. You certainly could start at the far left and then divide by 2 as you walk through there, but you'll have to figure out based on the length of it what the place is for the far left. You could certainly do it. That's the pattern of how this isn't a Python thing. This is the algorithm for converting a binary number into decimal. The far right value is the ones place. The one next to that is the twos place. So because of the way the pattern works, it kind of makes sense for us to walk it from the end towards the beginning. But we certainly could make the math work to go the other direction. All right, so place is equal to place times 2, and then pause is equal to pause minus 1. So we'll walk towards the beginning. All right, so this is what we're going to be repeating. As long as pause is not equal to -1, we're going to keep doing this stuff, accumulating our answer. All right, as soon as we're done here, we will go ahead and print out whatever our answer is. And our answer is supposed to be, what, a 10? There's our 10. All right, so if we put a bunch more zeros in there, what's this going to give us now? Still a 10. Because pause is still a 3. Pause we had hard-coded. We probably don't want to have values hard-coded. You know, we want this to generically work on any binary number. So we need to know what this position is. It used to be 3 because the length of it was 4 minus 1 is 3. So now we're going to say pause is the length of initial value minus 1. So we replace that hard-coded value with a generic version of it. Whatever number we're trying to convert, tell me how long that guy is. I want the last legal bucket, which is its length minus 1. Make sense? Good.
You don't put the -1 inside of these with the initial value. Does that change anything?
Oh, it would change a lot. What's initial value? This guy right here, right? That's initial value. So when you run your program, that's going to resolve. So it'll look like that.
Oh, no.
This doesn't make sense when you see it, right? Yeah, so sometimes when you're trying to figure out, well, why is something a certain way, go ahead and resolve your variables, put an example, in this case, we know exactly what the value is, but put an example value of the right type in there. And then when you look at it, you say, okay, well, I got a string that I'm trying to subtract a number from, might not make tons of sense. Got it? And that just comes from experience. Yeah. Say this again. No, in fact, actually, you don't want it to be length. This function right here, where am I at? Length. That guy operates on collections. So the length function, let's add that to the notes. That's a important enough thing to add to the notes. Let's say helpful Python functions. All right, so we have length. This returns the number of elements inside a collection. So from our perspective, this would be a string or a list. It can be a little bit more complicated than that, but we really haven't learned much about either of those at this point, but just collections of things. Strings are words that we're very used to using. Lists can be collections of anything. We can have a collection of a bunch of numbers, a collection of a bunch of Booleans, collection of characters if we want, that kind of stuff. We have some other collection types, but if we need to get the number of things in a collection, we have a function called len that's helpful for that. Similarly, int, this returns, and here I'm going to put it, most programming languages are case sensitive. All right, so this returns the numerical equivalent to non-int value. So if I pass it the char 0, it'll give me the number 0, so on and so forth. Yeah. It effectively is. So an array, so you have a background in C, C++, Java, something like that. That's where you're getting the word array from. Okay. So array and lists are very similar to each other. When we get into lists, there are differences, but for all intents and purposes, they're the same thing at this point. All right. So we have two little helpful functions here. We'll come back and add some more stuff if I bump into other things we need to know, but getting the length of a string or the length of some collection could be handy, and converting something that should be numerical but isn't technically currently stored as numerical also can be helpful. And as you might guess, we also have, I think there's another function called float that will turn, if you have the string 3.14, it'll give you the floating point value 3.14. So it kind of lets you juice things out of it, if you will. All right. So instead of hard coding a 3 here, which covered us when that was our only collection, now we can support any size collection, because what we do is we get the length of this entire string, whatever that is, and we say, give me its length, subtract 1 from that. That is the position of the last legal element in that collection. So in that case, we're saying, give me the position of that guy. All right, and just making that little change, here is now the decimal equivalent of that giant binary number. If you want to throw more zeros and ones in there, run it again. Now there's the equivalent of that binary number. Make sense? All right. Questions about that? All right. So what I'm going to do here, I'm going to save this. Let me copy this in case it does something funky. I wonder which one I'm logged in with here. I don't know who that person is. Let's go the other route. Whatever. Then I'll click share. And I'll put this into the slides. So this will always be that code we just wrote. We're about to make some changes to it, but it'll remember the current state with what we just did. All right. So now, well, before I go on, any questions about this code so far? Do we see how this is the Python equivalent to what we wrote here generically? Good.
Could you just say, like not the code, but just how do you like what is like the format for like converting the whatever the binary to decimal? I just need to make sure I remember like how.
Like what's the, if we were to do this by hand, What does it look like? Okay, so let me go back to our original value because I don't want to have to deal with that many zeros and ones. So first of all, we'll just prove this still gives us a 10. We've written it generically. All right. So before we write this code, what we're trying to do is we are trying to convert to decimal. All right, so this goes back to us knowing how to do this by hand. Then we're trying to write a program to mimic that. So we need to know the problem we're trying to solve. So I'm going to go ahead and write this number out. Put in some spaces there. And that's the ones, twos, fours. This is the eighths place, fours place, twos place, ones place. So this is 1 times 0 plus 2 times 1 plus 4 times 0 plus 8 times 1, which is equal to 10. If you want to see this differently, this is 2 to the third power, 2 to the second power, 2 to the first power, 2 to the 0th power. That's what those things actually are,
Okay.
those positions. So if we were dealing with, this is a base 16 number, which is this, if I told you this wasn't actually a binary number, if I said this was a hexadecimal number, does this meet the requirements of a hexadecimal number? Does 1010 meet the requirements of a hexadecimal number? Sure. What are the legal hextets that are allowed to be in a hexadecimal number? 0 to 9, then A through F. So 0 to 15. Yep. 0 to whatever the base is minus 1. All right. So is this made up of some values between 0 and 9 and A through F? Sure. So it is important that we tell you what base it's currently in, because lots and lots of numbers can look like they belong to other bases. This is also a base 10 number, right? This is 1010 if we were reading it as a decimal number. All right, so it's important that we know that it's binary. So this is always the base, the base, the base, the base. So if we're converting instead of base 2, we're converting to base 16, or from base 16, we would change all those 2s to 16s. Make sense? All right, so is that what you wanted to see?
Yeah.
Okay. All right, other questions about this dude? All right, so let's make this, before we make it a little bit more generic, let's break it. So I think my very next slide says, what if we wanted to convert BAD from hex to decimal? So now we go into our code here. We're going to say, okay, well, my initial value is now BAD. All right. Now we're multiplying place by 2 over and over again. We want this to work for different bases. So why don't I go ahead and create a variable here called base. And let's have that guy, we'll say it's currently base 16. All right. So now place times whatever base is. So place started off at 1, because 16 to the 0th power is 1. 8 to the 0th power is 1. 2 to the 0th power is 1. Anything to the 0th power is 1. All right. But each time through, we're going to multiply place times whatever the base we're working with is. And base currently holds a 16. It used to hold a 2. We want it to work like our code worked before. So if I go back to this, there's our 10 again, using a generic version of base. So we're saying base, in this case, it's base 2 because this guy's in base 2. So now it'll just multiply by whatever the base is. So now we're converting it. We're saying, okay, the same logic, because we've learned 2 patterns, right? The same, since we're converting from hexadecimal to decimal, I should be using the identical pattern to what we just wrote this code for. Code shouldn't have to change very much. So if I go to BAV, and I say that's currently in base 16. We're going to go ahead and do this. We're going to say is pause, not equal to -1. It's not. We're going to go ahead and get the current bit. Probably current bit is the wrong variable name since now we're technically getting a hextet. But let's not worry about that much. We'll just get the current bit. And that's going to be the initial value at position. Since this is 3 elements, the length is 3, so the last legal bucket is 2. What is the value at position 2? It's the letter D. So my question is, what do we expect that to give us? A problem. We expect that to give us a problem. If I walk up to you and I say, here's the letter D, tell me the integer version of it with no additional context. In here, we kind of know that, okay, that's probably one of the hextets, so that's a 13, right? You know, we might do the mapping, but in normal, we don't do math with letters of the alphabet in the normal world. So that's not going to work for us. Let's go ahead and see what happens. All right, so we'll go ahead and get a value. We'll try to convert it to an int. We see it yells at us, invalid literal for the function called int with base 10. You're giving me a D. Not going to fly. Now, there might be other versions of int that technically let us work for something different, but we're going to pretend like we don't know that right now. So the question is how do I make my D become a 13? What do I do to make D be a 13?
You can set like a variable, like variable D is equal to 13.
Okay, well, do we want to hard code it for A through F? We could. We certainly could. We could say, hey, we're working with hexadecimal. Let's just go ahead and store all of the values, all of the values in a that we would be mapping for this. We could just do the whole alphabet or something like that. Anything else? Any other interesting trick way we can make this work using what we already know? Okay. I'm going to create a string here called map. And we're going to have all right. So what is D right here? Well, yeah, so D is 0, 1, 2, 3. We got to add 0 through 9 before it. All right. So if I found the location of 3, that's at position 3. If I found the location of 8, that's at position 8. If I found the location of A, that's at position 10. Found the location of D, that's at position 13. It starts sounding pretty good. But then we have to ask ourselves, how do I find what position a particular character is? It seems doable, right? We just need to have a mechanism for doing it. We're gonna see this is going to be our gateway drug to writing our own functions. Because it would be helpful for us to say, you know what, if I had something else I could write, and I could just toss it a character, and it tossed me back a number, I'd like to be able to call that multiple times. But before we do that, since we don't know how to write our own functions yet, let's see if we can come up with a different approach. Go ahead.
Is there a way to convert like a character to its decimal value? Because then if you did that, you can just subtract it by 55. But the value.
All right. So let's go in here. Let's look at our ASCII table. Let's go and find D. So D is currently the number 68. We wanted to get to a actually, so we need to get it to a 13. So what do we need to subtract from a 65 to get us to a 13? You said the number, right? 55. So if I took whatever the ASCII value was and I subtracted 55 from it, that would give me the correct value. Does it work for numbers? What if I said, okay, I'm working with the number 0 here. If I subtract 55 from 48, is that right? 48? As opposed to D was up here. So 55. So if I do 48 minus 55, that gives us a negative number. Probably not going to fly. So really, we want to do this if we're dealing with a letter, right? If we're dealing with a letter. All right. Now, in our particular example right now, we're only dealing with letters. So let's kind of test this and make sure it's working for us. All right. So he's saying, you know what? For any of these letters, if I just subtract 55 from it, 55 from whatever the ASCII or Unicode value is, I will get the numerical value of that. All right, so we'll see if Python lets us do math directly. Otherwise, I'll have to look up real quick how to get the ASCII value out of it, but we can still write the thing the right way. All right, so because I'm going to leave this mapping thing up here for right now, because ultimately that's where we're going to go. So your solution is a lesson ahead of where we're going. All right, so because I happen to know for this experiment that all of our things are letters, we can test this whole subtract 55 thing and see if it still works, right? All right, so rather than saying give me the integer value here, what we're going to say is give me the current value, which is going to be a character. So in this case, it'll be a D the very first time through. And I want to subtract from that of 55. That will be the number that is our current bit. All right. Now, right now, this guy may or may not be mappable. If we were working with C, C++, Java, C#, if I have a character, I definitely, whenever I do math with it, it'll treat it immediately as its Unicode value. It's possible we'll have to say something in Python to say, give me the Unicode value of this guy. We'll see here pretty quick. Yep, so it treated that guy as a string. So it says the minus sign isn't supported for strings versus ints. So we need to get this guy to do it here. Python get Unicode val from char. Point, I think is the name of it. Ord. So that is going to give us the value, in this case, of D. The value of D is 68. And if we want to see that, well, here, let me just run this real quick. Oh, that's going to play a slideshow. That's not code. All right, so that's the right answer, by the way. BAD in hex is 2989 in decimal.
Decimal value for a decimal or
hexadecimal value for a character. I'm sorry, no, the Unicode value for a character. And I'll write it here in the notes. So we have this slide for helpful Python functions. So we have ord character, this returns the Unicode value of the character. So that allows us to extract the Unicode value from a char. So we're doing math with the character set, as long as it's not a 0 through 9. Make sense? All right. So if right now I'm working with hexadecimal values, actually, if I'm working with any value up to base 36, my code currently works. As long as I don't have 0 through 9 as part of the number, right? Go ahead. Right. It won't, this will not work for 0 through 9. 0 through 9, we've already seen work, right? We could just convert that to an int directly. But if we're dealing with any of these letters, we can get the numeric equivalent of that letter by just subtracting 55 from it, kind of using a math trick that takes advantage of our knowledge of how ASCII and Unicode work. All right. So the follow-up question is, if we really want to make this work, but we want to make it work universally, because right now, if I throw a 1 in the front of that guy, we're going to have problems real quick, right? Is that going to be an error?
No, it's just gonna subtract the.
We're getting some negative number action going on, right? A 1, whatever 1 was. So a 1 is 49. So 49 minus 55. We got problems. We got a negative number. Things are going to get interesting, but technically not an error, right? Good.
So you could do have the original code, then you can, if there's do a try.
Yeah.
And if there's an exception to it, then you can do the other method of getting the Unicode value.
Sure. Okay, now, so first of all, how many of you have no idea what he just said? Most of the people in the class. He's mentioning something called a try-catch. I'll show it. Not a difficult thing, but this is kind of why I say solve things in terms of what we already know, what's in our toolbox. It's a good solution to this one. Effectively, what he's saying, well, let's just try to turn it into a number. You know, like it works. If I give it a 7, the char 7, int gives me the number 7. Works great. But if I gave it a char D and I asked it to give me the number, it screamed at me, right? So I could try to do it. And if it blows up in my face, I can catch that error and do the other thing instead. It's actually a good solution to the problem, just a little bit of a more advanced solution to the problem. So let's go down a little rockier road initially until we get into some tricks. But you're right, absolutely. All right. I'm lost. All right. Oh, sorry.
You do the same like logic as that, but with an if statement and divide it into two separate, like treat 0 through 9 this way, treat 5 this way.
And that's what we're going to do.
Okay.
So it's going to be somewhat of a hack. So what I want you to get out of this is there isn't necessarily one correct way of doing things. So when you write your code, you're not trying to write things in the shortest possible way. You're not trying to write things in the fanciest possible way. You're trying to write things in the way that makes sense to you. All right? Because this guy that we're learning how to boss around is really, really, really fast. If you have the accurate answer written in the most inefficient way possible versus you have the accurate answer written in the most efficient way possible, there isn't one person here that would be able to tell the difference in the runtime of that program. Under the hood, if you actually measured, put them on the stopwatch, you know, you'd have milliseconds, maybe even less than that, speed difference between those two, but as a human being, we wouldn't notice. 99% of the time, probably more than 99% of the time, that comment I just made is a truth. Only in a very tiny number of circumstances is writing something in the most efficient possible way actually important. And I would argue that by the time you're at the point solving those types of problems, you're going to have a much stronger handle on the coding stuff where that won't be an issue. But right now, every single one of you should solve the problems in a way that makes sense in your mind. I have a former student, Nick Largen, still in the area, works for Northwestern Mutual, software engineer for them, making good money. He's been there for probably a decade now. I'll tell you what, when that kid was a student, I have never seen such backwards logic in my life. It worked, but just the way his mind went about solving things was just upside down from everybody else, but it made sense to him. You know, and it became like this ongoing joke during the 4 years, but he's turned into a pretty good software engineer and yada, yada, yada. So solve things the way that makes sense to you because that's how you're going to get better. If you have someone who's a little bit more mathy, they might know some kind of math trick or something like that. Your goal is not to be able to do things the identical way they're doing it at the cost of you not learning it. Do it in a way that makes sense to you, even if it's an extra 20 lines of code. Not the end of the world. All right, so let's look at this in terms of the tools that are in our toolbox. We're interested, right now we have if statements, we have variables, we have a little bit of loopy stuff. We got a couple of functions we've been introduced to. So what we're going to do is we're going to go ahead and we're going to get the current char. All right. So this guy right here is going to extract from our string whatever character is found at position pos. Could be a 0, could be a 5, could be a D. Make sense? We're interested in whether or not it is a 0 through a 9. If it's greater than 9, let's make sure this this works. So we see down here 9 is over here. If it's greater than a 9, greater than a 57, then we can say, oh, it must be a letter. But only, actually, we could always say it'll be a letter because upper and lowercase letters are after this. All right. So if it's greater than a 9, well, how do we ask that question? Let's go back here. If cur char is greater than the character 9. All right, we're gonna have to test this because we have to find out, does this guy let me compare a string to a string? Can I ask, is one character greater than another character? Or am I gonna have to do that ORed thing again? We'll go ahead and assume this is gonna work. Put the code in, run it. If it screams at us, we'll know we have to use the ORed thing instead. All right, so if it's greater than a 9, then we know that it must be a letter, so we need to do this ORed minus 55 thing. Otherwise, cur bit is equal to the int of cur char. And I'll use cur char here as well.
So what we've done in the if and else, what is our goal with?
Yeah. So let's look at just that code right there, only that section. So this very first line, line 16 says, give me whatever character is found inside of my initial value at position pos. That is going to be some character. Could be a 0, could be a 5, could be a D. Something between 0 and 9, A through F. Then we're going to ask a question about that. If that character is greater than 9, which means it's something further down the Unicode character set other than numbers. It's not between 0 and 9. Then, if it's something further down, we need to treat it using his minus 55 trick. go ahead and grab the Unicode value of whatever letter it is, subtract 55 from it, we now have math stuff. All right? Otherwise, if it's not greater than 9, it must be 0 through 9. And if it is 0 through 9, we know that we can just directly convert it to a number. Right? The character 7 becomes the number 7. So when all is said and done, when we get to this line right here, per bit holds a number one way or another. Good.
It's 550.
Only in this particular case, because he noticed the pattern that if I have any of these uppercase letters and I subtract 55 from it, I will get, well, here, if I have an A, 65 minus 55 is a 10. If I have a B, 66 minus 55 is an 11. And we know that A should be a 10. We know that B should be an 11, so on and so forth. So in this particular case, that's what we want to convert it to. We want an A to become a 10. All right. So now, moment of truth. We find out what Python lets us get away with. Is Python cool with us asking this question, or do we need to go ahead and do the org thing to work with it? The real question is the greater than symbol defined for working with strings? And it is. So there's my 2989. If I put a 1 before that, 7085. If I actually, a fun thing would be to go ahead and put in one of those memory addresses we had. So I'll just put a longer value there. There's the decimal equivalent to that crazy thing. Go ahead.
Since we're not referencing map, how does it know that like an A is greater than 9?
So know that then we just know. Oh, we're just asking a question right here. Think of this like a fork in the road, right? So we get to this if statement. We say, okay, I'm holding current char. That's something in my hand. I'm asking a question about this guy. I'm saying, is this thing, effectively what we're asking is this a number? Okay.
Got it.
If it's greater than 9, then that means it's one of those letter things. And if it's one of those letter things, we have to do this ninja move. But if it's not one of those letter things, if it is one of those 0 through 9s, then we do this ninja move. Any way you cut it, when we get to this line, cur bit has been set to the numeric equivalent of the current value we're working with. Go ahead. We're going to. Yeah. We're going to. In fact, I'll do it real quick here in a second. But so right now, this works for any base. If I go ahead and I say that this guy is actually base 36, but I keep this number, there's the number. It's a base 36 value, which we don't have a great use for, but this works because it's fully implemented that pattern. Go ahead.
Would you say current char is greater than 9? Do you mean just like the number 9, or do you place in the actual string? If it's
I mean this. If I'm holding current char and I'm saying, is that guy larger than this guy right here? The character 9. If it's greater than that, the Unicode. So really what I'm asking is it greater than 57? That's what it's actually asking. Not the number 9, but the character 9, which is equal to 57. This is where it is on the Unicode character set, is 57. An 8 is 56. A 7 is 55. So on and so forth. We have this giant scroll which is the Unicode character set. And it has for every single character in all of these different languages, it has a numeric equivalent that it maps to. So all we're saying is we're noticing that all the letters come after this guy. So since all the letters come after 57, that means if it's greater than 57, it's got to be one of those letters in this specific problem we're solving. All right, so now let's write our own function. Okay, so we're going to say we're going to write our own map function. This guy is going to take in a character 0 through 9. A through Z. Returns the numeric equivalent. For example, a 3 will return a 3. A 7 will return a 7. An A will return a 10. A D will return a 13, so on and so forth. That's what we want this function to do. All right, so rather than running out to Home Depot, coming home with this converter thing, think of it like a toaster, where we drop a character in the top and it pops out a number. We're going to say, you know what? I'm going to do this homemade. So we're going to make our own version of this guy so that whenever I need to do this conversion, I can just call my own little function. All right, so I'm going to take this string that we wrote, map. Let's see, let's do char to digit. This guy will take in a char as a parameter. We're going to put map in there. So what we want to do is we want to go through, look for a char, whatever that value is. If it was a 3, we want to look for that 3. This is bucket 0. This is bucket 1, 2, 3. So at bucket 3, we found a 3. Return that 3. At bucket 10, we found an A. At bucket 13, we found a D. So what we're going to do is we're going to potentially go through all the values that are inside that string. We know we're going to find one of them because we're working with 0 through 9s or A through Z's in this case. So we're going to say, I'm going to still do it as a while loop. We'll talk about for loops next class. So I'm going to say pause is 0 while pause is less than the length of map. So map is 36 characters long, all the numbers followed by all the letters in the alphabet. So that means 0 to 35 are the legal positions. So while pause, the current value of pause is less than 36, that means it's 0 to 35. We want to ask a question. If map at position pause is equivalent to the character we're looking for, whatever character was passed in, we're building an ability here. So I can call this guy 10 different times. I can pass in for HR the character 2. I can pass in for HR the character D. I can pass in for HR the character A. So this guy is written generically to work on whatever value was passed in here. Good.
Pause. Instead of less than map -1 because it's not touching 36. It only ever hits 35.
Right. If you were going to say -1, you would have to put an equal sign there.
Yeah.
All right. So if this is the character that we're currently interested in, we'll go ahead and return pause. Otherwise, pause is equal to pause plus 1. Now, I'll go ahead and I'll return a -1 if I never found it. So for instance, if I pass in a question mark, for example, the question mark is not going to be part of any of our numbers. We don't want to do mappings from a question mark to its numeric equivalent. So we'll return a -1 and say, hey, this is a problem, or you can throw some error, whatever you want. Go ahead. Probably. Where? Oh, because I'm programming in another language. I did it on purpose. Whenever I introduce errors into the code, I did it on purpose.
Well, usually it's fine. Usually it's fine.
Actually, I think Python would be fine with it, but it's not part of the syntax. One day you'll have programmed in enough languages that you get confused between the language. It's all the same crap. But yeah, thank you. See, you started for the day. You caught my trick. I was trying to stumble you. All right, so now I have this ability that if I pass some character to it, it'll find the mapping for that character and return the position it found it. Or if it never found it, once this while loop, ends a natural death. If it goes all the way through all 36 elements, never finds a match, it'll return a -1. All right, go ahead. Sure. Yeah. So he's asking about this indentation thing. I said early in the class today that maybe one of the only reasons I like Python is that it forces you to indent. Python says anything that you want to be governed by this while loop must be indented underneath that while loop. Anything that you want to be governed by this if statement needs to be indented under that if statement. So that guy is part of the if statement. This guy is not. Whereas if you're dealing with a language like C or C++, you would usually have curly braces that you use to do your indenting and stuff. And that's where beginning programmers are not forced into formatting their code, call it nicely. All right, so we've built this ability now. So now what I can do is I can come down here and rather than this whole if-else structure, in fact, I'm going to go ahead and just comment it out so you still see it. So you can do comments in Python by just putting little hashtags before it, or you can do 3 hashtags and 3 hashtags and it'll make a multi-line one, but I didn't do that, so such is life. So now what we'll say is we're going to say current bit is equal to char to digit cur char. I wrote this ability, char to digit. It's right up here. I wrote that ability. I'm going to go ahead and pass whatever cur char is into that. This guy is going to do its magic and ultimately spit out the numeric equivalent. The return keyword accomplishes 2 things. Returns a value from a function, makes a function immediately end. It's important that you understand both of those things. Not all functions will return values. We'll see plenty of examples where you want a function to just accomplish something but not really give you something back. Just happens. But sometimes you need to get out of a function before you do any more logic. Maybe you've gotten halfway through checking everywhere and you've decided, we're not going to find it here. Let's save some time and just bail. Return lets us bail out of the entire function. We have a couple of other keywords that let us bail out of portions of a function, but we'll get to those. But I would say that most of the time people view the return keyword in that light. I might suggest that the fact that it makes a function immediately end is actually a more powerful function of it. or powerful use of that.
You would usually line it up with the name of the function or whatever it is that you're using, like if you're using a while loop, it would be in that same line indentation.
That's too generic. Yeah, return can be wherever it needs to be. There isn't like a set, and we'll see plenty of examples of it.
Well, specifically in Java, it'll give you an error if you place a return statement inside of the parentheses rather than out.
It's not giving you the error about that. It's giving you the error that it says this function must return a value. So if you return inside the loop, even though we know we're going to get to this line here, in Java, if you left that return -1 off, Java would scream at you because there is no guarantee that we ever get to this line. Even though as a human, we might say, yeah, any data I'm going to pass this, we'll get to that line. Java says all functions have to return a value. If you've advertised, they're going to return a value because it's a strongly typed language. So not only do you have to tell it the kinds of values that you're holding, you also have to tell it the kinds of values that a function is meant to return. And if you say you're going to return an int, you better return an int. Java will scream at you if you don't. Python will not. So I could leave it like this in Python, and if it just happens to not return anything, it'll give us a value of none, which is kind of a null thing. I don't want to talk about that yet, but that's what it'll do. All right, so let's see this work here. 1 second, let's just get it going. All right, so I'm going to take whatever my char is. I'm going to pass it into my brand new function I just wrote. This guy will give me the numeric version of whatever that character is using your map approach. So there's that guy. Let's change it back to something that we can trust. There's my BAD, and there's 2989. Make sure I get this into the notes. All right, what's your question?
Back on the code, what's the difference between a parentheses and a bracket? What's that tell the machine?
Parenthesis and a bracket.
So like pause within a bracket, right? Line 14, if map, you've got map and
Oh. Map is a collection type. Pause is the position within that collection.
brackets.
The bracket, yeah. So this comes from when we had that chart showing the history of languages. C introduced arrays. Arrays are indexed using brackets. So this is Python just following suit with C and say, hey, you got a collection, you want to get a certain element from a collection, put the position of it inside the brackets.
Okay.
Yeah. So whenever you see the brackets, you're definitely working with a collection type.
Gotcha.
All right. And these things are things that you don't necessarily need to memorize. What I fully expect is that everybody in here right now can follow when I write it and I explain it. But if you were having to write it yourself, you would still struggle. That's exactly where you should be right now. Hence, you got to put the reps in. All right. A lot of reps led up to me just be able to type this unconsciously, but throwing obviously purposeful errors in there for you to learn. All right. Questions, comments, concerns, bribes. This way. Yeah, she asked, is the better solution to this problem this way, which I think makes reasonable sense what we're doing. The Unicode one is kind of the cool, geeky math trick version, but you might sit there and look like, well, why minus 55? Then you go and look at it and says, oh, I get it. So probably not great programming practice, but definitely geeky. Yeah.
Here, like decimal, which way do we usually read? We read it from right to left, right? Far right, all the way to the left side.
When we process it.
But then we are reading strings.
Well, because strings strings don't say what they're representing.
Yeah.
Strings are just a collection of characters. When we think of a string, we're usually thinking about holding words or stuff like that, where binary numbers or hexadecimal numbers, the pattern we use to process them happens to start at the end. This far right, yeah. But nothing says you have to do it that way. You just know the far right's the ones place, twos, fours, eights. Yeah, so it's, you can go either direction. Yep. And in the slides, I put a link to this on the BAD one, so you can open up this code exactly. I put it right here on the slide.
Yeah, I tried doing the plus equals.
Sure.
Plus equals